2 sine theta plus 5 equals 6.04 is a trig equation. A trig equation is an equation where the unknown, in this case the unknown is theta, the unknown is an angle that's part of a trig function. Basic trig equations like this one can be solved in 4 steps that really aren't too difficult. We'll talk about those 4 steps and solve this trig equation in this video. We do have some specific directions in this video. First, since the unknown theta is an angle, you have to know whether that angle is being measured in degrees or radians. In this statement, 0 degrees is less than or equal to theta is less than 360 degrees, indicates that theta is measured in degrees. Additionally, this statement is also saying that we're only going to find the answers to this trig equation, the solutions for theta, between 0 degrees and 360 degrees. Actually, most trig equations have an infinite number of answers, and this one does. However, we're only going to find the answers between 0 degrees and 360 degrees. We'll discuss how to do that as part of solving this equation. Additionally, the solutions to most trig equations are irrational, and here we're being asked to round to the nearest tenth of a degree. Let's begin. Step 1 is to isolate the trig function. In this equation, the trig function is the sine of theta. So we're going to isolate the sine of theta using basic algebra. First, we'll subtract 5 from both sides of the equation, and when you subtract 5 from 4.04, you get negative 0.96. And then there's one more step to isolate the sine of theta, and that would be to divide both sides of the equation by 2. When you divide the left side of the equation by 2, the 2's divide away to be 1, and on the right side, negative 0.96 divided by 2 is negative 0.48. So at this point, we have sine of theta equals negative 0.48. The trig function has been isolated, and it's on to step 2. Step 2 is to identify what quadrants the solutions are in. As I said earlier, this trig equation, like most trig equations, has an infinite number of solutions. We're only going to look at the solutions between 0 degrees and 360 degrees. This table represents whether the 6 trig functions are positive or negative depending on the quadrant. Here, our trig function is sine, so we'll be focusing on the top row of this table. And we have the sine of theta equals negative 0.48. The sine of theta is negative only in the third and fourth quadrant. This table indicates that the sine function is negative in the third and fourth quadrant. We will have 2 answers to this trig equation between 0 degrees and 360 degrees, and those 2 solutions will be located in the third and fourth quadrant. Now the third quadrant are angles between 180 degrees and 270 degrees, so one of our answers will fall in that range, and the second answer will be in the fourth quadrant. It will fall between 270 and 360 degrees. On to step 3. Step 3 is where we're going to use an inverse trig function. We're going to take the inverse trig function of the positive version of the number. So here we have the sine of theta equals negative 0.48. And what we'll do is we'll take an inverse sine, but it'll be the inverse sine of positive 0.48. We'll evaluate inverse sine of positive 0.48. Now this will be irrational. This step will usually result in an irrational number. As the directions stated, we're going to round this off to the nearest tenth of a degree. The inverse sine of 0.48 is about 28.7 degrees. Remember, in step 2, we determined that our solutions would be in the third and fourth quadrant. 28.7 degrees is a first quadrant angle. This is known as a reference angle, and we'll use this reference angle to find the third and fourth quadrant answers. to this trig equation in step 4. Step 4 is to use the reference angle formulas, which we'll discuss in a second, to state the two solutions. This is the last step. This is where we'll find our two solutions. Remember, in step 3, we found our reference angle, 28.7 degrees, and in step 2, we found that our solutions between 0 and 360 degrees are in the third and fourth quadrant. The reference angle formulas are these. If theta is a first quadrant angle, in this case it is 28.7 degrees, to find the associated angle in quadrant 2, you'll take 180 minus theta. To find quadrant 3 will be 180 plus theta, and the associated angle in quadrant 4 is 360 degrees minus theta. Remember, back in step 2, we identified that the solutions to this equation would be in quadrant 3 and quadrant 4. So we'll be using the third and fourth quadrant reference angle formulas. Using the quadrant 3 reference angle formula, 180 plus theta, in this case 28.7, 180 plus 28.7 is 208.7 degrees. This angle of 208.7 degrees is one of the two solutions to our original equation. The second solution will be located in quadrant 4. So, quadrant 4's reference angle formula is 360 minus theta, or 360 minus 28.7 in this case, and that difference is 331.3 degrees. And this is the second solution to our equation. So at this point, we do have our two answers. We've completed step 4, and we have the two answers to the original equation between 0 degrees and 360 degrees, and those two answers are 208.7 degrees and 331.3 degrees. I want to finish this off by checking those two solutions. To check the two solutions, our quadrant 3 solution again was 28.7 degrees, and our quadrant 4 solution was 331.3 degrees, rounded to the nearest tenth. To check the quadrant 3 solution, 208.7, all that I'm going to do is take this 208.7, substitute it for theta in the original equation, and make sure that equals about 4.04. It's not going to be exact because we rounded this off to the nearest tenth. Substituting a 208.7 into this original equation, the sign of 208.7 times 2 plus 5 is 4.0395. Again, it's not exactly 4.04, but it's close enough. Since we rounded off to the nearest tenth, we can be confident that 208.7 is correct as one of our two solutions. We can check our other quadrant 4 angle the same way. Substitute for theta, 331.3 degrees, and we can see that when we take the sine of that angle, multiply by 2 and add 5, we also get 4.0395. This is irrational. It goes on forever without ending, but it is, at least to the nearest tenth, 4.04. This answer checks out as well. The two solutions to our original equation, 2 sine theta plus 5 equals 4.04, between 0 and 360 degrees are in fact 208.7 degrees and 331.3 degrees.